Hello all, we are ready to finish up the unit on polynomials by giving you some crazy stuff to work with. So hopefully at this point you are comfortable with the difference between adding and subtracting polynomials, how to multiply polynomials, the area model, all that stuff. I hope you are comfortable with that up until here, because here I'm going to show you some crazy stuff that just looks intimidating. But just with hard work, put your nose down and just get going, and careful work, you're going to find success. So I'm giving you 5 problems or 5 expressions that need to be simplified. And the 5th one, kind of a word problem with a crazy area question, because I love those. Those are fun. So we're going to get through each one, and then we'll be able just to power through. There's no new concepts to cover in this lesson. It's just how does applying all the previous concepts plus hard work pay off, right? So that's what we're going to focus on. So if you look at number 1, you see this expression, and you probably get intimidated by all of the symbols. And so you have to remember one basic thing is that brackets are simply large parentheses. So we're just looking at large parentheses. You don't need to be scared of these brackets. So I'm going to copy this problem down, and then we'll see what it looks like, and then we'll be able to apply some stuff. So we have our first expression, and hopefully what you're recognizing immediately is that this is a perfect square binomial. So you're looking at a perfect square. Well, not a binomial, but anyway, it is a perfect square. We have something being raised to the second power. And so we have to recognize from the last lesson that this indeed is a perfect square. And if you remember how a perfect square works, it's that little form that we had talked about in that last lesson on special products. And so that's how a perfect square works. And as you see, this is exactly what is occurring, right? And so we have a plus b raised to the second power, a squared plus 2ab plus b squared. That's what's happening here. It's just our b looks a little crazy, right? Our a is here, but our b looks a little bit crazy. So if we have an a here and a b here, what would this whole crazy expression look like? And so we're just going to apply that, right? And so what we're doing is looking at this the form from the perfect square. And if our a is 3, well, then a squared is 3 squared. And then we have 2 times a again, 3, times b. b is 2x minus y. So hopefully you see what just happened, right? This is our a, this is our b. Our b is funny because our b is a big group, right? So if we're using b, then that's what the b is. And then we have b squared. So b squared is this crazy thing squared, right? So if we look at just the first setup, and if we're able to follow this, and we're careful with our work, then everything's going to be just fine. So just put your nose down and be careful, right? So now we can just start multiplying some stuff out, right? 3 squared is 9. 2 times 3 is 6. Look how careful we are working. And then plus, well, we have 2x minus y raised to the second power. And so again, another perfect square. And remember how a perfect square works. If we have a minus b to the second power, that was a squared minus 2ab plus b squared, right? So if we have to remember that from the previous unit, or the previous lesson, and we can just apply it here. So we're just being careful with what we're doing, and we're showing our work step by step. Just put your nose down, show your work, and be careful. Everything will be just fine. So a squared here is going to be 4x squared minus 2ab, and then plus b squared. All right, so we have that whole binomial totally multiplied out, and then being careful with the rest of the expression. So again, step by step, keep your nose down, but be careful. So we'll move on to the next stage of this, right? Now we have this to multiply. 6 times 2 is 12, so 12x, and then minus 6y. So we've just multiplied this distributive property. So hopefully you've caught what's going on. And now we're simply adding that last polynomial. And so we have set up this very crazy expression. So again, it's just step by step, hard work and careful. Nose down, show your work, be careful. And that's pretty much it. Now we're going to look for some like terms to combine. We get 9s, x's, y's, x squareds, x, y's, and y squareds. Guess what? There are no like terms. So we are done. So all we have to do is just order some stuff correctly. So how do I like to order things? I like to go alphabetically. So I'd go 4x squared plus 12x minus 4xy minus 6y plus y squared, and then that positive 9 at the end. Don't forget that guy. So we have this crazy polynomial, and there's nothing else to combine. That's what we have. There are no more like terms, right? We have 9 ones, and everything else is x's or y's or xy's, and that's it. Right? So everything is about being careful and keeping your nose down. And so when you're not intimidated by symbols, you can know what to do and just be careful while you're working on it. And so now we'll work on that second expression, and that one's also possibly intimidating at first. Okay, but if we're able to what I call zoom out, see things for their groups and all that stuff, we can perform things a lot better. So here's that second expression that we had. And as you can tell, this is a little bit nuts, right? So we have, again, brackets and parentheses and all this crazy stuff going on. But hopefully you're able to recognize what's happening. Do you recognize these two things as conjugates? Right? Do you recognize them as conjugates? Right? Remember, if this is A and this is B, and this is A and this is B, A minus B, A plus B, remember what conjugates multiply into? A difference of squares. Okay, so you got to remember that special products lesson. Okay, so hopefully you're able to recognize things because of grouping symbols. Just A is funky. That's all. A is a bit funky. So what? So what? A is funky. Don't be so prejudiced. A looks a little bit different. We don't treat it differently than anything else, right? So A is funky, no big deal. We can recognize A minus B, A plus B. Now we can multiply our conjugates. So how does this work? If we're multiplying conjugates, that means we have A squared, but remember what A is. A is that crazier looking thing. Doesn't mean we treat it any differently. That's A squared, right? And then minus B squared. So we're able to recognize, we're going to set up, and just get to work, right? So recognize, set up, get to work, and be careful. So now we have this expression, and now we're going back to, hey, we got that perfect square again, darn it. All right, so you remember how perfect squares work. A squared plus 2ab plus b squared. And so we'll end up with 9x squared plus 2ab. A times b, 12xy, double it, 24xy, and then b squared, 16y squared, and then minus 25 at the very end. All right, so we have expanded our polynomial. Now we look at our expression. Do we see any like terms? There are no like terms, so we are done. Recognition, hard work, and care. Okay, so that's basically it. When you're dealing with challenging things that are happening, recognition, hard work, and care. Okay, so that's what those first two expressions would look like. So now, what happens if we start to multiply more than one polynomial? Again, care, hard work. Right? So just be careful, show your work, and keep your nose down. Just get the job done. Everything will be just fine. So if I'm looking at an expression, I'm multiplying 3 polynomials, no big deal. It's the same thing, no different than multiplying any other 3 numbers. You can multiply 2 at a time and then multiply the third one. It's the same as what we've normally done. So for example, if I had 2 times 5 times 6, how do we do that? Multiply any 2 of these and multiply the third one. We can tell, well, 30 times 2 is 60. Or 10 times 6 is 60. Or 12 times 5 is 60. It doesn't matter. Either way, you're coming up to 60. 2 first and then the third one. So that's what we can do here. Any 2 of these first, and then we'll multiply the third one. So I'll multiply these 2 first. And you can multiply it by any of the models that we used in the previous lessons. But either way, let me do a think aloud. Watch what I'm going to think as I multiply this one out. X times x is x squared. Are you listening? 2x minus 3x. 2x minus 3x is minus x. And then negative 3 times 2 is negative 6. Okay, so I just went ahead and did that. Hopefully you were listening. And that's what those first two are. And now I can multiply my, my third binomial. Okay, so it's 2 at a time, and then multiply the third one. So here we are, back to, again, the previous lesson on multiplying polynomials. And so, again, distributive property, x to the fourth plus x squared, and then minus x to the third minus x, then minus 6x squared minus 6. So I'm just using the distributive property. You can use the area model. It doesn't matter how you're doing this, but you can get it done. And then we can look for our like terms to combine. So I have my x to the fourth. Here's an x squared and an x squared. Minus 5x squared. And then minus x to the third minus x minus 6. But hang on. I will not mark someone incorrect for this expression. However, let's keep what's called descending order. And descending order means our exponents go down in order. So the exponent here is to the fourth. This is to the second. This is to the third. This is x to the first. This is x to the 0. Right? So I'm just going to rewrite the polynomial in descending order. So I have x to the fourth minus x to the third minus 5x squared minus x to the first minus 6x to the 0. And then I'm just going to write it in descending order. But again, at this stage in the game, I'm not going to mark anyone incorrect for not doing that. Just we will have a time where that becomes important. So far, so good, I hope. So what's the key? Recognition, hard work, and being careful. All right, so now we look at the next expression. What do we have here? Number 4 is a crazy looking one. As you copy it down, so will I, so I can show some work. And hopefully you recognize some stuff. If not, that's okay. This is a fun one. I like it. So here we have number 4. Here's this expression. Do you recognize what's happening? I hope so. We have here conjugates, right? For multiplying conjugates, difference of squares. All right? And so we have that polynomial and our original polynomial. Okay, so those previous lessons come in. Now, what's happening? Do you recognize a perfect square? So hopefully you do. And how do perfect squares work? We have a minus b to the second power, a squared minus 2ab plus b squared. You recognize that? So we have x to the fourth power, right? Minus 2x squared y squared plus y to the fourth power. And that is what we would have. Now, can you show your work a different way? Can you use the area model? Absolutely. Okay, feel free to use whatever method you would have. That's how we would work with that. Okay, so we have some complicated polynomial work going on here. Now, how do we apply this to area? So if we have a word problem, I'm asking this. What is the area of the shaded region? So we see a large rectangular figure that has certain polynomial dimensions and a smaller rectangular figure with polynomial dimensions. How would I find the area of the shaded region? Well, it's very simple. It's understanding the concept of, a missing piece. So if I found the area of the large rectangle and I subtract the area of the small rectangle, you know what I would end up with? I would end up with the area of the shaded region. Isn't that cool? So that's how we would approach this. So hopefully you're thinking, in terms of how would I get to that shaded region? It's hard to piece this up, but if I take the whole thing and subtract that little piece, I would end up with the area of the shaded region. So let's approach that. What is the area of the large region. So the area of the large region is, well, my length, or width, whichever way you're looking at it, this side, 7x minus 3. And my width, you would think it's 3x plus 2, but look carefully, it's not. It's 3x plus 2 plus this 2x. So we have to be careful, right? Isn't that cool? This is 3x plus 2 plus this 2x. So the width is 3x plus 2 plus the 2x. So I have to be careful with that. And then the area of the smaller region, simply x plus 4 times 2x. And so we're going to calculate our areas momentarily. And so once we see what's happening, we can then apply our plan of action. Okay? So we're going to find the area of the large rectangle. Area of the large rectangle, length times width. Okay, so again, our length was 7x minus 3, and our width is 3x plus 2x plus 2. Okay, so our width is 5x plus 2. So that will be the area of the large. Okay, so this is the area of the large rectangle. And so I'm going to multiply that out. And so if I multiply this out, again, think aloud. 35x squared plus 14 minus 15 plus 14 minus 15x is minus an x, and then minus 6. So the area of the large rectangle is 3x squared minus x minus 6. The area of the small rectangle, so remember that was the plan, is x plus 4 times 2x. Okay, so the area of the small rectangle, simply 2x squared plus 8x. Okay, so I have my two areas. How would we then find the area of the shaded region? Subtract the 2, find the difference. Okay, so we're going to follow our process. The whole thing, again, see things, be clear, and just get your nose down and work hard. So what we're going to do then is subtract our small rectangle. And now from whatever results we would have, So we'd have 3x squared minus 2x squared, of course, is an x squared, and negative x minus negative 8. Negative x minus negative 8. Negative x plus 8. Positive 7x, and then minus 6. So this is the area of the shaded region, that many square units. Okay, and that's how we would approach shaded region area questions. So we're just using funky polynomial work, we're doing a little bit of geometric applications. But again, the lesson is see things clearly, work hard, and be careful. Okay, take care, and then you'll be a master at polynomials. Thank you so much.